with the old and in with the new. If you've still been using y equals mx plus c, that's fine, but I'm going to show you a more efficient and useful formula. It looks complicated, but trust me, it's not. It's just the way it's written. But the way we describe it is completely different. Now, let's just revise what y equals mx plus c and how do we utilize it. Now, y equals mx plus c is how we describe a straight line, where m is the gradient. It's a fixed number because a straight line has a fixed gradient. And your plus c represents where the line crosses the y-axis. So it's very specific. You should really use this only if you know the y-intercept. This, on the other hand, is the equation of a line generally, meaning you can know any coordinate on the line. Now, how does it work? Let me prove it to you. So let's say I have a coordinate axis here. Here's my x-axis. Here's my y-axis. And all my GCSE students use this one, by the way, and they much prefer it because they just know how to apply it super quickly. Now, on a straight line, how many points do you need to know in order to know exactly what the straight line is? You need 2. Because if I put a point here, I could draw an infinite number of straight lines through that point. However, if I do that again, so remember the point was there, if I do that, all I need is another point here, and I know exactly what the straight line is. So I need 2 points. Now, one of the points I need to know. Yeah, you need to know one of the points. I'm going to call it, here, I'm going to call it x1, y1. So in maths, we call this coordinate that we know x1, y1. Yeah, so we know this. Okay? Then we need a generic coordinate, a coordinate that could have gone anywhere. I'm going to put that here. That is your xy. Okay, the same xy that you have in your y equals mx plus c, that's generic. Okay? Now, between these 2 points, what's fixed? Remember, it's the gradient. Now, the gradient is your change in y divided by the change in x. So we're going to form a triangle, a right-angled triangle. And we're going to work out what's the change in x and the change in y. And you find that through subtraction. So to go from this x coordinate to this x coordinate, you take them away. So it's x take away x1. For example, if this coordinate here was -1, and this coordinate here was 5, the distance between them is 6. 5 take away -1, the double negative becomes plus, it is 6. Okay, so that's all I'm doing. Remember, this is generic. Then on the y-axis, you take them away. Y take away y1. And what did I say? I said that the gradient is fixed. The gradient is m. M is the change in y over the change in x. So m is the change in y divided by the change in x. Then all we do is multiply through by the denominator, and then we're done. First, we put a bracket around this and multiply. We're going to get m lots of this is this. And that's proved. Okay? Even at A level, students don't need to prove it, but we need to know how to utilize it. So guys, you just need to say it 5 to 10 times. Y minus y1 is m, x minus x1 is a very nice formula, in fact, when you read it out loud. But to my GCSE students, we don't actually read it as y minus y1. What do I actually tell them? I say y minus the y coordinate is the gradient x minus the x coordinate. Okay, that's a better way of saying it. Y minus the y coordinate is the gradient x minus x coordinate. So let me show you how it works with some questions. So let's look at part A. Use the y minus y1, m minus x1 formula to find the equation of the line that has gradient 2 and passes -1, -2. So remember, guys, x coordinate, y coordinate. So we're going to do y minus the y coordinate is the gradient x minus, so x minus the x coordinate. Well, the double minus becomes plus. We expand. So we have 2x plus 2. And then we add the 2. Okay? And that's done. It's a lot more efficient than using y equals mx plus c. I'm going to use the y equals mx plus c formula on both examples to show you guys the difference. So this is the y minus y1. If we're doing y equals mx plus c, you would first say y equals mx plus c. Then you need to work out your plus c by doing your substitution. So y is 2, x is minus 1 plus c. You would then say 2 is minus 2 plus c. Then you would add that over, is 4 is c. And there you go, y is 2x plus 4. You get the same answer, but in many more steps. Okay? Now it becomes way more important with these kind of questions where we get fractional gradients. Okay? So let's take a look at when fractions are involved. So I've given you guys 2 points. Well, the first thing, no matter which method we want to use, which guys, you're free to use whichever method you want, is we need to find the gradient, all right? We find the gradient by doing the change in y divided by the change in x, okay? Now, I don't use y2 minus y1. It's very easy to make mistakes. What I do is I line up the coordinates. So I have 7 minus 6, and I do 3, 4. Just like if you guys were to subtract really big numbers, you would do column subtraction. We do the same thing here. So we're going to take them away. 7 minus 3 is 4. Minus 6, minus 6 minus 4 is minus 10. So my gradient is the change in y divided by the change in x, which is 4. We can simplify that, minus 5 over 2. Now, this is the same no matter which one you want to use. But this is where the two formulas really differ. And this really is just much better. So, we're now going to use y minus the y coordinate, etc. But the question is, which coordinate do you choose? In fact, you can choose any of them because both of them determined what the gradient was. So I'm going to do 3, 4 just because they're both positive. Y minus the y coordinate is the gradient x minus the x coordinate, which is 3. Okay, now that's it. If you guys want, all you need to do is expand, move that over. However, traditionally, when we have fractional gradients, they like the form to be ax plus by plus c is 0, where everything is integers. We don't like fractions. So what I'm going to do is I'm going to multiply everything by 2 to get rid of that divisible by 2. Remember, this is all one term, so we need to do it once. So that goes. So we have 2y minus 8 is, now that's just minus 5 because we multiplied by 2. So we can do minus 5x. And then we have minus 5 times minus 3 is plus 15. Then we're going to move everything over to this side. So we have 2y. The minus 5x on the other side is plus 5x. The plus 15, move it to the other side, becomes minus 15, minus 8, minus 15 is minus 23, is 0. Okay? So, 3 steps. 3 steps. Yeah? There should not be any more than 3 steps when you use this formula. However, the same can't be said for y equals mx plus c. We're actually going to need a lot of space for this. So, let me rub this out. We'll get there eventually. All right. So remember, these steps here are fixed. All right. So we're only going to compare this section. 3 steps. Okay. So with the y equals mx plus c, you would first say y equals minus 5 over 2x plus c. And then you would substitute in a coordinate. And keep in mind, I'm doing this without a calculator. Okay. So we're really thinking about, in a non-calculator paper, which formula is better. Let's sub in 3, 4 again. 4 is minus 5 over 2 times 3 plus c. Now we need to make sure we don't make a silly mistake. We're multiplying 2 numbers. One is a fraction. 1 we could write as a fraction if we want. 3 over 1. The 3 goes to the top. 4 is minus 15 over 2 plus c. Then you need to add that over. Okay, so we're going to get 4 plus this. And then we need to say, okay, that's 4 over 1. So I need to times top and bottom by 2 to make sure the denominator is the same. that'll be 8 plus 15. So we get 23 over 2 is C. So we have y is minus 5 over 2x plus 23 over 2. Then we need to multiply through by 2 to get into the same form as what I had. So we had 2y is the 2's cancel, minus 5x. And then here, 23. And now we just need to move everything to one side. 2y plus 5x. And then the 23 on the other side is minus 23 is 0. Okay? Guys, I think there's a clear winner. Yeah? Even if you could move that over and maybe skip these two steps. Yeah? Well, maybe not these two steps. You'd probably need to keep that one. Say you remove this one and you say, okay, I could do it. You still got 1, 2, 3, 4, 5, 6, 7, 8 steps. 1, 2, 3. There's definitely a clear winner. But it's up to you guys. All right? Y minus the y coordinate is the gradient. X minus the x coordinate. We can do a lot easier algebraic calculation and simplification and manipulation with this one. But let me know what you guys think. If you learned something today, I really appreciate if you hit the like button, subscribe for more maths content, and if you're interested in submitting your own questions and getting feedback from the community, join the Lung Gang on Reddit, link is in the description. And if you're interested in my GCSE maths courses, more details in the description. See you in the next one. Nice.